You know, every now and then, a single research paper comes along that just completely changes everything. Today, we're going to talk about one of those moments. We're jumping back to 2019 to look at the OpenAI paper that introduced the world to GPT-2. This is the paper that really set the stage for the AI revolution that we're all living through right now.
All right, so let's just start with the huge, almost philosophical question the researchers were chasing. Just think about this for a second. Can an AI actually learn a skill that it was never, ever explicitly taught? Could it learn how to translate a language or summarize a big article just by reading a whole lot of text? That was the big idea they were shooting for.
Now, to really get why that question was so wild, you have to understand how AI was usually built back then. The old way, what we call supervised learning, was kind of like having a giant toolbox. You had a specific hammer for nails, a specific screwdriver for screws. Every AI model was a specialist, trained very carefully for one and only one job. The new idea? Totally different. It was asking, hey, can we build a single Swiss Army knife? One model that just learns a bunch of different skills by soaking up tons of raw, unlabeled information? And this really gets to the core of the issue. I mean, don't get me wrong, those specialist models were powerful, but man, were they brittle. An AI that was an absolute genius at spotting cats in photos would be totally lost if you asked it to even write a simple sentence about a cat. It knew its one job, and that was it. This hyper-specialization was a huge roadblock if you wanted to create more general, more flexible AI. So that brings us to the big bet, the core idea of this entire paper. What if the key to making that generalist AI, that Swiss Army knife, was actually a ridiculously simple task? What if you trained a huge model with just one single goal, get incredibly good at predicting the very next word in any given sentence? Could that one simple objective unlock all these other complex, sophisticated skills? And that is exactly what the title of the paper means, an unsupervised multitask learner. Let's just break that down real quick. Unsupervised means it learns all by itself from raw data. There's no one holding its hand, no one labeling stuff for it. And multitask means it picks up the ability to do lots of different things, not just one. So you've got an AI that basically teaches itself how to be good at a bunch of stuff just by finding patterns in the messy chaos of the internet. Okay, so how'd they do it? How do you even test a hypothesis that big? Well, the recipe in theory sounds pretty simple, but you got to understand the scale here was just completely unprecedented. It all came down to two key ingredients: a massive amount of text data and a massive neural network to learn from it. First up, the data. They couldn't just grab any old text. No, they needed high-quality, diverse stuff. So they actually created a whole new data set called web text. And their method for this was really clever. They went to Reddit and scraped the internet by following links that people shared, but only from posts that had at least 3 upvotes, or karma. The thinking was, hey, if a human thought it was good enough to upvote, the content is probably more interesting, right? This whole process gave them a whopping 40 gigabytes of text from over 8 million different documents. All right, now for ingredient number 2, the model itself. And the key word here, the most important word, was scale. They didn't just build one model, they built 4, and each one was a huge jump in size and complexity. They just kept ramping everything up, the layers, the depth, and most importantly, the number of parameters, going from around 100 million all the way up to, well, the really big one. And that largest model had 1.5 billion parameters. Now, today, that number might not sound crazy, but back then, that was absolutely massive. You can think of parameters as all the little knobs and dials inside the AI that it can tune to store all the patterns and knowledge it's learning. And 1.5 billion of them gave it this incredible capacity to learn. Okay, so they built the models. They trained them on that one simple goal: predict the next word. Now comes the fun part, the magic moment. It was time to test these things on tasks they have never, ever seen before. We call these zero-shot tests because the model gets, well, 0 examples. Zip, nada. It just has to figure it out on the fly. And the results? They were just stunning. First up, reading comprehension. They gave the model a passage and asked it questions about it, questions it had never been trained to answer. And it worked. The data showed this super clear pattern. The more parameters the model had, the better it got at the task. Scale was literally creating skill right before their eyes. Next, they tried summarization. Could it read a really long article and just give you the main points? Yep, it could do that too. And it showed the exact same pattern. That biggest 1.5 billion parameter model was just dramatically better than all the smaller ones. The evidence was really starting to pile up. Making the model bigger wasn't just making it bigger, it was making it smarter.
But this is where things get really wild. Translation. Remember, this model was trained on a giant pile of mostly English text. It was never given, say, a French sentence next to its English translation. Yet somehow, just by getting really good at predicting the next word, it had implicitly learned to translate between languages. This was a truly mind-blowing, unexpected ability.
So the charts and graphs were all looking amazing. They were proving the hypothesis was right. But what really captured the world's imagination, what really blew everyone away, wasn't the data points. It was seeing what this thing could actually write.
And this brings us to the famous unicorn story. The researchers wrote this short little prompt. In a shocking finding, scientists discovered a herd of unicorns living in a remote, previously unexplored valley in the Andes Mountains. Even more surprising to the researchers was the fact that the unicorns spoke perfect English. They fed that little snippet to GPT-2, and it just took it and ran with it, continuing the story with perfect coherence, talking about a Dr. Jorge Perez, evolutionary biologist, the whole thing. It wasn't just stringing words together, it was actually telling a story.
So, what's the lasting legacy of this paper? It's actually really simple, but so profound. GPT-2 proved that scale isn't just about making a model bigger for the sake of it. It proved that scale is a direct path to making a model smarter and more capable in ways you might not even expect. I mean, the paper's own conclusion just nails it. A big language model, when you train it on a big and diverse enough data set, can get good at a whole bunch of different things. The real breakthrough here wasn't some fancy new algorithm. It was the deep realization that the brute force of scale could unlock potential that we never even knew was there.
And this idea, this scaling hypothesis as it came to be known, well, that became the fundamental blueprint for everything that came next. GPT-3, ChatGPT, all the amazing generative AI tools that we have today, they are all direct descendants of this one core discovery. Bigger models and more data leads to brand new emergent abilities.
What this paper did was lay out a clear roadmap for the entire field of AI. All of a sudden, the recipe for making progress looked almost simple. Step 1, gather an insane amount of diverse data. Step 2, build an even bigger model. Step 3, train it with a simple goal. And then step 4, sit back and discover all the incredible new things it's learned how to do on its own. So in the end, the magic of GPT-2 wasn't just about what it could do back in 2019. It was about what it represented. These surprising, unprogrammed skills, they were a clear, powerful glimpse into the future of artificial intelligence. It was like looking through a keyhole and seeing a whole new world on the other side. And that leaves us with this final fascinating question, right? This single paper proved that scaling up can unlock skills like creative writing and translation, things that felt like science fiction. So as we keep pushing this idea with even more data and even more powerful computers, what completely unforeseen abilities are just waiting to emerge next?